Okay, so what we're going to talk about is one command that we don't use a lot, and so we're basically just going to look at it, and that's the math command. And I'm doing this right after we did the configuration, and it really doesn't matter. But let's take a look at the math command, and well, we just use it to put it in as just a demonstration purpose. And basically, the only function that we use, if you have this math, you have a result, and again, we want our result, we want to put in a DS register, and you can put any type of formula. So let's just take a look at, I've got my DS, I'm going to call this DS10, and when we use it, we kind of put in a formula where we can put in, if we want to increment something, we can just say DS10, and once it knows that it is a register, it's going to highlight it like that. And if we just want to increment it, we're just going to say +1. So now that's going to be what our new result is. It's just going to increment. It basically does the function of a counter. And we either have it as a counter, so it counts up, or it counts down. We can use different registers, and the main purpose is for some of our animation, we just have it count, and we have it count at a really fast rate. We either count up with, well, I just didn't want to put that there. But we have our timer, and this counts at a 1 second rate. We could have it count, say, 10 times faster, and we could use that type of math instruction. I'll put the math instruction, I'll put it all the way at the end so we do no harm to our program. So I'm going to insert a rung afterwards, and let's pull up our math. So we can put in these DS10, and again we're saying that it's DS10 over here, and we can say +1. So we can go in here and just going to have this increment. So every time it gets to the bottom of the program and it does the recycle timers, then it'll just execute this. And actually, we could use the recycle timers as something that would just time out. And actually what we can do is, rather than do the recycle timers, we can say that every time, if we are counting this one, so we can count in half-second intervals. So every time that went high, which that's only also going to go high once we get beyond that set point. So we could actually, well, we can do this. I can add another rung, and I'm going to basically, I'll put in another timer, and I think this one needs to be timer 4. I don't know why it's called yellow on, but instead of it counting up in half-second intervals, I'll make it count 10 times a second. And again, I'll have it count when we're in the start process. So my start process here is C2. And what we use these things for, and again, what we use them for is we have fast counters, and we use them for animation. So we want something to move across our screen, and like the cup carriage in the Wonka machine, or any type of animation, we can increment it to get it to move from left to right. We can decrement something to move from right to left, or up or down. It really doesn't matter. Now I'm going to make this one a normally closed T4. So anytime we're in start process, this is going to run, and it'll run 10 times a second, and this counter out here is just going to count 10 times a second, which you would say, well, why don't I use a counter? And you could. Now the only, and let me add one more in here as rung afterwards, and I'll just copy this. The one feature that and I'm going to copy and paste it, what you can do here is, obviously you can take this math instruction, now I'm going to make this DS11 because I want a different register, is, you can count by 2s or you can count by 3s. Can't do that with a normal counter. But we also have things where you can, you can do any type. If you need to calculate, the area of a circle, it has pi in here. You can square it. You can do different things. It has tangent functions if you have to do some calculations. We don't do those type of things. Here is a modulo that if you had something repeated, if you wanted to count up to 6 and then start over and count from 0 to 5, and then the 6th position is the same as the 0 position, you could use modulo of 6 and that would help you out. You can also do things you can do in hex format, and again, we don't do any hex format, but those are all different things you can do with that, and this is pretty good. Now you can have also functions, so you could say I want to do this. So when this is counting here, I can you could have this, so when I press the push button, you can either have it execute one time. So if the push button is enabled, you only execute this function one time. If it's not in one-shot mode, it's going to execute that every scan for as long as you have the finger on the push button. So if you're slow on the push button, and that didn't take hold, I want to make this 11, and I want to make this one 11, and I didn't hit OK was the problem. So if I was having the start push button, if it was in one shot, it would only execute this once. But if I had my finger on the push button without the one shot mode, if I have my finger on there, and even if I'm quick on the finger, it might execute that in 6 scan periods. If I'm slow on my finger on the push button, so my finger's staying on there for a while, it might execute this command 50 times. So you need to be careful about using these math commands as to whether it needs to be one shot or not, so you don't, especially when you're adding things together, if it's doing it over several scans, your number is going to, instead of doing, and let's say we're in this one I want to increment by 2, instead of counting up 2, 4 every time you press the push button, it might be like 2, 12, 18, 30 if you're not in that one-shot mode. So you need to be careful about that. And again, I'm talking too much about this feature that we don't really use. So what we're going to do is we're just going to look at the outputs here. Again, this will be a free running timer, so we're just taking a look at these outputs and you can see their values. So we'll connect up to our PLC, we'll write this code in, and we'll just turn on the code so you can see it running and see what these do. And again, the only reason we use it is just for animation purposes for the HMI. Otherwise, we can, for everything we need with the the trainer, we can just use simple counters. But it's another thing that we thought we might just show you. So here is the actual value, and when we turn on this start process, this is when this timer is going to start timing, and we can take a look at the outputs here. This one's going up by every time this timer times out, which again, it's going to be 10 times a second. This number is going to increase rapidly. So you can see how these numbers are going up, and this one is double the other one. So that's the way the math function works. Now, a lot of times, and so why do we do this in animation anyway? A lot of times when you're moving something across the screen, fully across the screen, you need big numbers, and you like these numbers because the higher the count, the more granular it looks, or more actually smooth or analog it looks as it's moving across the screen. If you have small numbers, it would have a tendency to kind of jump around if you're not counting quick and not counting to high numbers. So that's what we use it for, and I can only think of couple instances when we've even tried it, and I'm not sure it's in our final, well, it's not a final code, but I'm not sure we even use it at this point in the code at all. But it is another thing to use and experiment with, and maybe you can figure out some good way to actually use math besides just incrementing, decrementing, or here we're counting by twos, and that's a little bit of a function that you can't use with the counter. So you might have to think up a project, but it does have some value, and we just needed to show it to you to let you know that that's available. So that's what we have for the math instructions. So thanks.